had a typo in the part C of the last problem. I believe I fixed it, so I want to try this problem just one more time. So here I have the limit of this big, ugly, rational function. So where are we going to start? I'm going to start by plugging in 2. Let's see what happens. So 2 to the third minus 3 times 2, times 2 squared plus 4 divided by 2 to the fourth minus 4 times 2 cubed times 2 cubed plus 7 times 2 squared minus 12 times 2 and plus 12 there at the end. So in my numerator, let's see, 2 to the third, I've got 8 minus 2 squared would be 4 times 3 minus 12 plus 4 divided by, in my denominator, 2 to the fourth, I should have 16 minus 2 to the third would be 8 times 4 minus 32 plus 7 times 2 squared, that's 7 times 4, that would be 28, minus 24 plus 12. Plus 12. All right. So let's see, in my numerator, I know I'm going to end up with 0. In my denominator, let's just double check the arithmetic, and you can do that at home, and yep, we end up with 0 over 0. So we have this indeterminate form. Let's try to apply L'Hopital's rule here. So I'm going to do it in red just to kind of show that we're taking the derivative now. I still want the limit as x approaches 2. Derivative of my numerator, I have 3x squared minus 6x divided by, in my denominator, I have 4x to the third power minus 12x squared plus 14x minus 12. So okay, I've used L'Hopital's rule. Let's try this limit one more time here. So let's see, 3 times 2 squared minus 6 times 2. In my denominator, I have 4 times 2 to the third minus 12 times 2 squared plus 14 times 2 minus 12. And let's see, 2 squared would be 4 times 3 is 12 minus 6 times 2 is 12. In my denominator, let's see, 2 to the third would be 8 times 4. I've got 32 minus 2 squared would be 4 times 12 minus 48 plus 14 times 2. I've got 28 minus 12. So numerator's not too bad, 12 minus 12. My denominator, let's just double check the arithmetic, and oh boy, 0 over 0. So I guess we'll try L'Hopital's rule again. We ended up with 0 over 0. Let's try it one more time here. So if I use L'Hopital's rule here, I still want to look at the limit as x approaches 2. Let's see, derivative of, I'm looking at this guy right now. So the derivative of my numerator and the derivative of my denominator. So the derivative of my numerator, and actually let me highlight that again just so that I don't lose that. Derivative of my numerator, let's see, I've got 6x minus 6. In my denominator, I have, let's see, 12x squared minus 24x plus 14. So let's try it one more time. Let's see if this works out. So here I have 6 times 2 minus 6 divided by 12 times 2 squared minus 24 times 2 plus 14. So here, let's see, 6 times 2, I've got 12 minus 6. This is looking promising. Divided by 2 squared would be 4 times 12. I've got 48 here minus 48 plus 14. And oh my goodness, ladies and gentlemen, don't look now. 6 over 14, which ends up as 3/7. Hey, there's my limit. As soon as we end up with something that is not 0 over 0 or infinity over infinity, that's it, we're done. So our limit ends up being 3/7. So you may have some problems where you have to use L'Hopital's rule more than one time. You may need to use it 2, maybe even 3 times to arrive at a solution. But again, just make sure that you're showing that you end up with that indeterminate form before you apply L'Hopital's rule.